is using the calculator to do some stuff, and we certainly use it a fair bit in this topic. If it's something that the calculator can do for you to give the answer, then you're certainly encouraged and you should use the calculator to do it. Okay, so last lesson we looked at this idea of the binomial distribution and looking at the probabilities of an event occurring. And so up on the board is just the example that we did quickly go through, where it's the full sort of working in terms of expanding it out so that we can look at, this is an archer who's shooting at a target and has a 90% chance of hitting the target. And so if we have 5 arrows fired, then there are sort of 6 possible outcomes in the end. All right, they could miss every time, which if they've got a 90% chance of hitting the target each time, you would think is a very, very low probability. Okay, and it works out to be 1/10 to the power 5, which is a very low probability of missing all 5. And then you go to 1 hit, 4 misses, 2 hits, 3 misses, etc., 5 hits. So there, the outcomes, the probabilities are through that expansion. Yes, you can do the expansion, and yes, you need to know how to do it because the exams are very clever at putting in questions where it might be something is a K or an unknown or whatever, so you can't put it in the calculator. However, your calculator does have functions to be able to help you to solve some of these things. And there are 2 possible things that need to be solved. One could be that you just need to work out the probability of 3 successes, 3 hits. Okay, so for an example of that, yes, you could go, okay, if it's 3 successes, I know that I have to do the combination of 5 trials with 3 successes. So you use the combination button and that will give you 10 and you multiply by that. So you can certainly do that. But in your calculator, if you go to the second function variable button, so it's the distribution you're looking for, so second distribution, and you're actually going to have to scroll down past, we're actually going to use these normal PDF and normal CDF and inverse normal later. We use that in the continuous random variables. So the similar ones though, if we go down here, you'll see the binomial PDF and the binomial CDF. Think of the C as standing for cumulative. We're not doing cumulative in this question, we'll do one next. We're going to do just the probability of an event occurring. So we want to go to that function and it'll bring us up to a screen that we can put some information in. We need to put in how many trials are we doing. So in this we had 5 shots of the arrow. The P that we're putting there is the probability of the success. So we're talking about hitting the target as being a success. Okay, so the probability of a success is 90%, so 0.9. Okay, and the X value is how many times do you want that success to occur. So if I said I wanted to get 3 hits, I put in 3. You'll enter, it actually pastes that value or that into your menu and you just hit enter again to get the answer, and it tells us it is 0.0729. That's the probability of getting 3 hits, 2 misses. Now, we don't have that, they haven't put that as a number here, but they do have probability of hits twice only, so we can check that. Distribution, go through your list to get to it, we can press A. So to change this, all I need to do is go enter for 2. Okay, and we get the 0.0081. There's your 0.0081. Okay, so that's a lot quicker as a method to be able to put it in. It's certainly acceptable. The one thing though, when you do write it into a test or in the exam, if you're going to do that because it's appropriate to do it, just write this line here, right? Binomial PDF bracket 5, 0.9, 2. That tells the person that's marking it what you put into the calculator. So if you put the wrong value in, then we can see what the problem is. If you've written the right values and you've got the wrong answer, question what's going on with it. But we can see what you've done. The other type of question you might get is to say, well, what about if it was at most 3 times? Okay, so at the most they're happy to get is 3 successful hits. So you could get 0 successful hits, that's okay, 1, 2, or 3. So it's really adding up all of those values there. This is where it's much more beneficial to use the calculator because otherwise you have to do all of that work. But your calculator is programmed to, when you put it in, actually we'll go to it. So we're going to go to the distribution and we're going to go to the cumulative one, the one that works out more than one probability and adds them together. Okay, you'll notice it looks exactly the same, so you just have to be a little bit careful. This is binomial CDF, so be careful, it looks the same. We have 5 trials. The probability is still 0.9 of a success, but the X value changes what it means in this little program. Your program, both the Casio and the TI are programmed. The X value that I put there, it includes that value and does all the values below it. Okay, so it says I'm going to include, if I put in 3, it's going to include 3 hits, 2 hits, 1 hit, and 0 hits. Okay, so for this question, it's I want to put in that because they're the ones I want. Okay, so that works out nicely. So if we put in 3 and paste that in, all right, we get the 0.0815, 0.08146485. Okay, that's the way it's programmed. Now, that looks nice on that question. If I scroll down to where they've put some questions into actually doing the using the calculator, okay, this question here says 72% of union members are in favour of a certain change to their condition of employment. A random sample of 5 members is taken. Find the probability that. Okay. In part B, it says at least 3 members are in favour of the changed conditions. Okay, so we want at least 3 are in favour. So if I go into my distribution, okay, in this one it is still 5 trials just because it happens to be 5 members this time. That's just by coincidence in those questions. Certainly that value will change at different times. Okay, so we've got 5 members that are being surveyed. We're talking about a 72% being in favour, so 0.72. Okay, so a success or being in favour in this case is 72%. We want the probability, this is part B, we want the probability that at least 3 of those members are in favour of this, these changed conditions. The calculator, if I put in 3, the calculator is going to say, what's the probability of 3 successes plus 2 successes plus 1 plus 0 successes? That's the way it's programmed. We don't want that. Okay, because we don't want, we want the 3, but we don't want the 2, 1 and 0 to go with it. We actually want the 4 and 5 to go with it. We want 3, 4 and 5 to go with it. But your calculator is not programmed to go up in the values. It includes the value you put there and all the ones below it. So what I'm going to do is say, put a 2 there, and the value that I'm going to get is going to be the value for 2 people in favour, 1 person in favour, or 0 people in favour, adding them up. That's not the result I want, but that's like the opposite. I want the 1 take that result because the whole probability should be 1. So I'm going to put that in, paste that, okay? That's going to be the so that is the probability that 0 people are in favour plus 1 person's in favour, or probability of 1, and plus the probability of 2 people in favour. That's what the calculator has calculated for me. I don't want that answer. I want 1 take that answer. Okay, and so I just have to do that extra step, and I'll get the 0.862. And if I have a look here, you can see the answer should be 0.862. Okay, so you do have to do the 2 steps for that. You have to think about it. Only Narav yours might be able to deal with that. I don't know. Some of them, the newer ones can. Yeah, I'll show you in yours in a second. Okay.